Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond. This is episode 19 of the Web Platform Podcast. Your hosts today are myself, Eric Isaacson, Senior UX Engineer at 3 Pillar Global, and Christian Smith, Startup Enthusiast and Open Source Developer. Today we're going to be talking about Node.js security and application security in general for the web. So mostly focused on Node. Today we have Chetan Karande. He is a developer, a senior developer and tech lead over at Omgeo. And Omgeo is a Thomson Reuters company. And they have been doing a lot of Java work, but they do have some Node in their development environments. Obviously, most of us do today. If you're in front end today, most things are powered by Grunt or Gulp or NPM in general and Bower, and all these things run on top of Node. So it's pretty extensive, the reach of Node.js. And so specifically today, we'll be focusing on the application pieces, building with frameworks like Express.js, plain old Node.js, a little bit of the other frameworks we'll talk about, but dealing with the security layer, which by default sometimes is not always as intuitive as it is in other backends that you may have used. Chetan and I used to work together at Omgeo, and back then we were doing a lot of front end work. I was in a different group than he was, but we managed to catch up in between breaks and lunches and talk about front end and JavaScript and what was to come of JavaScript. It was sort of a bastard child back then, and a lot of people didn't really see the power that we saw in it. And Chetan was focused on the YUI framework. I was big into jQuery and modularizing jQuery widgets, and that was another lifetime ago, it feels like. So I'm really happy to chat with Chetan today.
Definitely. Thanks, Eric. I remember Eric and when we were working, we used to mostly talk about front end stuff. I used to stop by on Eric's desk and we were talking about this new cool thing, single page apps coming in future. And we used to amaze all the things that is happening.
It's a fad.
So YUI was our best source to know about it at that point. But anyway, things moved on a lot after that. So at work, I still don't use Node much beyond development phase, but my other projects, like I was a contributor to OWASP NodeGoat project, and that was my transition mainly to the Node.js environment and knowing more about security aspect of it. And in general, that is kind of my passion about learning security aspect of any of the emerging technologies. That's how I was hooked with the Node as well.
How is Node.js different when it comes to building secure web applications?
Right. So overall, I think there are a few things which are different in Node. If we just start with overall web application security, the weakest area in modern web applications which is vulnerable to most of the security attacks, is environment configuration. So that includes things such as server misconfiguration, using outdated softwares, and using some insecure deployment related methods. So those all things still apply to Node.js. But here, specifically for environment configuration, traditionally that area was considered as outside of the application code. So when we used to get any server, it comes with dozens of features that probably we don't even use. It comes with dozens of configuration switches that we need to tune in. So Node doesn't include all of that, right? So we get very lightweight core and we assemble our application server on top of what we get as a core. This also means that we developers are more responsible for configuring that server. So we need to tune it a little better, and overall developers need to be aware of all the security related issues relating to just configuring the application itself. So that way I think it is more, security is more dependent on developers, because here we kind of build our server on our own. The second way Node is different is just because of its dependencies on NPM modules. So that is big source of vulnerabilities here, because our application directly depend on all these third-party modules And we have to be kind of diligent, or even kind of sometimes even hard to know if those dependencies have any vulnerabilities. So that way, that is another challenging issue for Node. And third thing which I can say, which is different in general architecture wise, so Node leveraging the single thread event loop, that makes it a little more susceptible for denial of service attack, where for example, any exceptions through uncaught exceptions in asynchronous code can crash the server, or if attacker manages to keep that event loop staying busy, then that could also cause denial of service issues. So these are a few things which are different in Node that I think that needs some more attention as compared to other traditional platforms.
So not that it's weaker, it's just different problems that you're facing.
Yeah, it's not necessarily weaker areas. Those are kind of also strengths of Node.js. It's just there are side effects around that. So definitely we want lightweight server. We want all those NPM packages that we can leverage. And also we want single thread architecture to do asynchronous things. It just, there are other consequences that we should be kind of aware of.
But Node at its core doesn't take care of the security by default. Is that what you said, or did I misunderstand?
That is kind of, in a sense, Node takes care of security at its level. So if you go on Node's website, there are vulnerabilities that are published in the Node itself. So Node vulnerabilities are getting fixed pretty promptly. Those get published on Node websites. But again, Node is pretty general. So we are kind of shooting for one specialized area of that, which is building web applications on top of Node. And there, Node comes with just basic HTTP server, and it's our responsibility to build application on top of that. So there, probably it's not kind of even in the area of Node's responsibilities to fix those areas. So it is very dependent on the way we develop our web applications.
It's a good point that you bring up that it's not just application architecture, but that's what we're focusing on today. But a lot of companies like Walmart Labs and LinkedIn, they've used Node as the service layer, for instance. And there's also front-end build tools using Node. You can't really talk with a front-end developer who hasn't used Node, whether they know it or not. As far as Express and Meteor and these other frameworks that are built around it, do you think that there's specific gotchas for each one of them, or do you think that they're sort of on the same playing field?
I think there's definitely differences. So the higher sophisticated framework you use, it comes with little security features as well. So let's start from the basic Node itself. If you're just building your vanilla app with the Node HTTP server, you will have to take care of a lot of security issues on your own, for which there are middleware available if you choose a little higher level framework. Just to take an example, if we take cross-site request forgery, if you are using Express, it comes with module for that, CSRF module. It comes with Helmet package, where it helps us easily add all those headers, security headers in the responses. If we are using core Node, you'll have to take care of that on your own. Now that is the case with Express. If you go one level higher, I'm not relating to the kind of one level higher in the sense little later versions. If you go with Koa, that is totally built with generators, and it reduces async code and callbacks drastically. So that helps in tackling those uncaught exceptions a little better, because those uncaught exceptions in asynchronous code were causing the event loop thread dying a lot of times. So if you're using Koa, probably you will eliminate some of those issues which were happening in asynchronous code, and specifically the uncaught exceptions that were coming from the asynchronous code. Now, if you move on to the Meteor, that is even more powerful. So they have this security mindset even in their design. So for example, Meteor doesn't use cookies for sessions. So they use local storage tokens for all author kind of user recognition. And that reduces the whole class of attacks which were dependent on session cookies. So for example, in cross-site request forgery, those cross-site request forgery is an attack where an evil site can take actions on behalf of any user. So in that, what happens, once user is logged in, an attacker can trick user to open any other page, and that other page can send requests. And since those requests are going to the same domain, browser automatically attach any cookies that were received from that domain. So now when it comes to Meteor, since there are no cookies and tokens are in local storage are totally separate for each website. So in that case, you are kind of protected against CSRF by default by not using session cookies. And Meteor also provides another feature for type checking if the inputs are strings and arrays. So those are few additional things that Meteor comes with. So overall, I think each framework comes with its own benefits related to security, and it's up to us like what level you want to adopt it.
I didn't even realize that about Meteor. And they just recently had a 1.0 release, I think, right?
Yeah.
It feels like it's been around forever, so it's kind of interesting. But it's a very different group of developers with Meteor, a very different style of programming in Node, and Koa as well. So it's kind of interesting. As far as these type of security attacks, you spoke about the cookies and the sessions and using local storage versus that. What are some typical ways that if I'm building a Node application, like what is the low-hanging fruits that I can quickly eliminate as far as working with JavaScript in the server?
Sure. Yeah, I think that is a good question. And I think it is really easy to kind of shoot a lot of those defects by just doing some tweaks. So for example, um, content security policy is one of our best ally, I can say. It is not supported in some of the IE versions, but it is still widely accepted now. So content security policy headers is very small work to add it. So if you're using Helmet, so Express, for example, Helmet module comes with methods to add those headers. So what those headers would do is it can restrict source of the scripts that are getting downloaded on your page. So you can limit the source scripts downloaded only from the same domain. So that will take care of any type of injection attacks, XSS attacks. So that is definitely one thing I would suggest using content security policy headers. Second thing we can do is to protect those cookies, because cookies is the most attractive target for an attacker, because cookies are like an identity of a user for the server. And we want to protect those session cookies mainly from the attackers. And Express session has some attributes. When you create Express session, you can set some flags there. So one of the flags is HTTP only. If you set that, that will prevent scripts from accessing cookies. That will foil a lot of XSS attacks which aim to steal those cookies. There's another flag which is secure, which would send those cookies only on secure HTTPS network. And that will also take care of eliminating some of the risks which come with script injection. So it requires HTTPS network for sending those cookies. So and for CSRF attack, there is CSRF middleware. So if we just use tokens for CSRF in our forms, that will take care of CSRF attacks too. So those are just few minor configuration items, very kind of no-brainer. There's nothing much significant work required around it to add it, but kind of that will take care of a lot of low-hanging fruits, I think.
I recently had a project where I was working with IE9, and I don't know if you're familiar with how some of the security works, but we had to deal with X domain on there, and that was pretty painful. It didn't support CSP, so we had some very strange cross-site issues with dynamically loading pieces, which were not related to security per se, but it's definitely a frustration doing cross-browser.
Yeah.
As far as tools that you've used or that your teams have used for doing static analysis, can you talk about that?
Sure. When it comes to tools, our still best friend is JSLint or JSHint. It does take care of a lot of code-related issues. And I think now most of the UI developers know that eval is evil, so we don't use evals anymore. So JSHint helps in identifying those type of issues. But even beyond that, there are some good configurations which can be possible through JSHint and JSLint. So one of that is just kind of checking the code complexity as well as number of paths that is going in the code. as well as checking number of parameters that is passed to a method. So if we could even identify those issues which are kind of in the code, that reduces a lot of business related attacks. So for example, a lot of business issues or some attacks that can be exploited because faulty logic, I think that come because of having complex code itself. So developers end up adding logic after logic and the code becomes too complex, and then there are some cases which are not handled. So tools like JSint also help us in identifying the complex code. So I just wanted to highlight that feature of JSint that we can leverage. Besides that, definitely use strict is kind of using strict will help you in reducing some of them. That is also taken care of by JSint checks. So definitely linting is our best tool. Now the other thing which is very specific to Node is our dependencies with NPM modules, and it's kind of a tough challenge. We want to know first when the modules that we are using are outdated, and second if they have any vulnerabilities which are unknown in publicly known. So for the first challenge, when we want to know if our packages are outdated, npm itself comes with little less known command called as npm outdated. So when we install Node, npm get installed on our computer, and most likely we all have used npm install. But there's another command npm outdated. So that command will go through our package.json and scan our package.json for the dependencies that are required there, as well as dependencies that you have installed and dependency, the latest version of those dependencies available on npm module, npm repository. So that is kind of a good tool to just run it frequently to see if there are any newer versions of modules available. Again, you won't be able to use those modules without testing first, but still it's good to know that you are using outdated versions, and if it is possible, you can try to keep it up to date by running either your tests first and making sure nothing breaks by upgrading. So npm outdated is definitely one more command that is helpful. There's a third tool which I would recommend, static analysis tool, is retire.js. So retire.js also kind of scans your package.json to see what modules you're using. And there it is linked with the Node Security project, and there it knows the vulnerabilities which are available, which are known in those modules. So it will just give you the list of modules which are not secure anymore. So having that tool also, and also it comes with Grunt plugins, so you can integrate it with your build process as well. So Node Security project also comes with command line tool to scan the things which is somewhat similar to retire.js. So you can use that as well. But retire.js also scans other JavaScript files which are not just Node modules. Those are a few tools related to static code analysis that I can think of.
So Adam Baldwin's a developer who worked on the Node Security project, and that's basically a site that would go through and tell you about vulnerabilities, whether they're patched, what version of Node they were in, and that really gives you a good idea of what you can expect with different versioning of Node in your applications, because we have a lot of these modules in NPM. They need to be updated, and sometimes you need a certain version higher than this, and then when you upgrade those, some things break and other modules, and some things don't. So it's nice to have this overall, these are the vulnerabilities that you can see. Do you have trouble with the different versioning?
Yeah, the versioning in the sense, the bigger challenge is that we have to kind of keep watch on vulnerabilities or issues that are reported on the node. So I think the best source is their website. I will share the link after the podcast, which keeps on, which is kind of good source to know which versions have security issues. So overall, we want to keep our versions up to date. We want to keep the latest we use the latest stable version of Node itself. And same thing applies even to the framework. So if you're using Express or Koa, we want to make sure that we use the latest stable versions of that as much as possible.
Chetan, can you give us an idea about the OWASP NodeGoat project? This is your project, isn't it? What is it, and how did you get started with this?
Yeah, so OWASP in general, probably for those who don't know, is kind of non-profit organization. It stands for Open Web App Security Project. So their main goal is to make security issues visible to developers and in general everyone so that people can take informed decisions. They have a lot of projects. Their most known project is OWASP top 10 list. That is one of their flagship projects. You can propose a project with the OWASP if you have some specific idea. So that's how I approached OWASP for this NodeGoat project. So OWASP already had a project called as WebGoat. So WebGoat project is a vulnerable application for OWASP top 10 risks. So that is kind of a very good project, and that teaches all about that teaches the OWASP top 10 risks and how to mitigate them. The challenge which I saw with that is I wanted to know how to do it in node specific way. So some risks are very specific to node, and also their fixes are very specific to node. So for example, if you want to fix CSRF attack in node, probably it won't help to know how it is done in Java, which is what NodeGoat uses. That's why I wanted demonstration side or some kind of documentation on how to address it in node specific way. And that's why this project comes in picture. So OWASP NodeGoat project is basically vulnerable application, which is vulnerable to all OWASP top 10 risks. It is built on Node, Express, MongoDB. And it comes with a tutorial guide. So the tutorial guide explains each of those attacks, how it was manifested in that application, and with the source example, how to fix that. So the source code is on GitHub, so anyone can clone it, run it locally. You feel free to fork it, and any contributions are welcome too.
Yeah, it's a great project. I've cloned it and I've run it, and it's great to see an actual implementation to test because you really can't go to somebody's site and start pen testing their code, right? So when you're doing it locally and you're able to see how these attacks work, and you did a great job going through everything, I think it's a great project for people to contribute to if they want to help in this area, and also lift securities logs and that list that you just posted.
Yeah. I think another benefit of contribution, at least that was for me, that I learned a lot when I worked on that project. So if definitely want to learn more about security, it definitely helps in getting more involved in projects like that.
How is Node.js used at Omgeo, and what are the challenges or discoveries that you've found?
Yeah, so in Omgeo, it is mainly Java-based shop, so we do not use a Node for production environment, at least as of yet. But we leverage Node for development environment. So we have all our build tools for UI, front-end development is all built on Node. So a few things related to security that we tried to experiment there was we wanted to something which I can share about that is just to do code analysis for security threats. So we wanted to try something to integrate in our node-based build system that can scan for the security attacks. And we tried to leverage this another project from OWASP, which is called as OWASP Z attack proxy, OWASP ZAP project. So it is basically penetration testing tool that is also a proxy, intercepting proxy. So it basically tracks all the requests going between your browser and server and tries to analyze that for security. So that is something we try to integrate with build system earlier. So in that project, probably I think I can, even if anyone is interested, I can share our findings with that. So it definitely is required to have running functional tests for these type of things. So you should have your functional test written in Selenium or any other tool that you're using. That way you don't need to manually drive those interactions.
What would be a typical example of one of those tests?
Right. So one of the tests it does is a cross-site scripting attack. So when you, for example, have a form which you're entering, it would try to enter some of the XSS specific strings there to see if it reflects back in the response. There's just one example there. So but overall, I think that is still like, there are some type of attacks for which these automated scanning tools are good at, extremely good at, like SQL injection, XSS. And there are some type of attacks where these tools won't help you much. So if there is something related to business logic itself, then probably it's hard to know about those problems through such automated scanning tools. So that is one thing to note about it. So it's not kind of comprehensive. So it's not that once you integrated it and then you are done. So you'll still need to do some manual security testing despite of that. Another thing to know is probably at least initially you will get a lot of false positives. So you might need to scan those reports or at least manually go through those reports and see which of them apply to you. And in the Grunt plugin, you can ignore some of those rules, but at least initially you'll have to go through that process to see what results you're getting and tune it a little further.
There's like three different types of security tools that I'm familiar with, some more than others. Static analysis tools, definitely I'm familiar with those. And there's tools that would perform the functional tests like Selenium, combined usually with, something like Mechanize or some, Phantom.js or something to do that. But there's also this idea of testing the binaries, and there's some tools that do that specifically. So I know that a lot of Node modules, they come out as binaries. Maybe not all the most popular ones that we use, but is there any problems with using those and getting those to be secure?
That is a good question. I can't think of anything as of now. So this is definitely a emerging trend, like using binaries for modules, but unfortunately I didn't do much research around that.
Fair enough.
So can you tell us more about the manual part of security testing? And I mean, once you get past all the obvious tools, the things that are automated, things like that, how would a developer or a team go about getting started with formally penetration testing their own code as they go along? Is there a feasible way to formalize that? So just like you have a suite of integration tests, that you would have a suite of security tests that are custom to your application?
Right, I think that is a good question. So I think it very much varies by product to product. So I don't think we'll have a ready-made suite of tests for security. I think we'll have to build it initially. So when the right way to do it is probably when we get the requirements, we'll have to also come up with possible security attacks, those requirements when we implement it, and come up with some test cases for that. So I would still think that it is very much manual process. It's just developers being aware of those attacks would help a little bit in coming up with those test cases. But ultimately, we'll have to do it manually and then include that as part of our regular testing, or then automate that as part of Selenium or any other tools that we're using.
That actually brings up another good point, which is how do you sell this stuff during the requirements phase? Like, so many technical organizations are actually driven by accounting, and the possibility of being hacked is something that a lot of non-technical decision-making people, they tend to greatly underestimate that. And so as a result, it sometimes appears that working on security doesn't really matter to the bottom line. Let's just ship features and not worry about doomsday scenarios. And as an engineer, how do you sell the bosses on the extra work that this is going to take up front? Do you have any good insights there?
Right. So I think if engineers have to sell security to upper management, then we have even bigger problem than just addressing that one challenge. And it has to be kind of overall decision for the whole organization. And I've seen some organizations using some tools to just justify that. So again, we possibly can't fix each and every security attack by code, and even it won't be feasible or even practical to build kind of bulletproof application. So we'll have to live with some open vulnerabilities in our code. It's just we have to do trade-offs for that. And that is where I think we can come up with some kind of compelling cases for the management. So there's one tool which generally used for assess these issues is called as CVSS, which stands for Common Vulnerability Scoring System. So again, this is kind of a little beyond the responsibilities of engineers, but if you really feel that there are some open issues, then this tool, CVSS, comes with a calculator which gives you the scoring for the risk that you know of, and it considers a lot of factors in that. It has its own way to come up with a number. So if you can come up with some numbers, and then if you provide that concrete information to your management, probably it's a better way to discuss it than being it a little difficult to quantify for management to support it.
On that same note, how can developers help make security a higher priority? One way of thinking about it is you go the Google route, right, where you do your stuff on your own and you bring it to the company, and the company may adopt it or they may not, right? And if you did that here with penetration testing, you're going to get arrested. So you really can't go penetration test other people's sites, because then there's laws against that sort of stuff. So getting into this sort of stuff is a little scary for application developers, I think. And the legalities of it for business might be a little scary, but the reality is, you pay now or you pay later, just as Evan Light said on our pair programming episode. If you don't take security seriously, then security is going to get the best of you, right? How do developers basically help make security a higher priority to avoid those security retrofits at the end?
Right. Fighting against these security attacks, I think our best resources are the developers itself who knows about these security attacks and they think about security when they do the coding. I think to answer your question, just having more awareness about the security attacks within the developers will help them in making better technical decisions. So it may not be really costly effort to fix it or do it in right way if there is awareness. So in general, this is what I think about at least Node application security is. It's not much a war against complexity. It's more about awareness. I'm sure Node developers solve much complex problems than what is required to make their application secure. What is required to make it secure is just knowing about basic OWASP risks at least to begin with, and knowing few things like, for example, keeping your Node modules up to date, keeping Node and Express or your frameworks up to date. If we even take care of those low-hanging things at developer level, I think we're still at a pretty good state.
Yeah, for some larger corporations, that's even harder, where they'll have like their own internal NPM, and then they're locked down to a version until their security group goes through it. How do you feel about having separate silos for security and application development? One way of thinking about it is that you have this separate group that just focuses on security, and you have this other group that focuses on applications. Or do you feel that the two should be knowledgeable of each other and work together?
Yeah, I think that is the latter part is definitely the good thing. So for the example, though, the one you gave about NPM having team is analyzing them, that definitely seems pretty good thing to do, though. I mean, if there's someone within an organization is taking care of scanning all those packages for you and making sure those are kind of good to use, that is definitely a good thing. But in general, though, just coding without security in mind and then leaving security testing at the end for someone else, that doesn't seem like a very good idea. So in that case, probably developers can help a little better and kind of do those security related or think about security right from the beginning when they do the designing and coding. That is also kind of much cheaper or easier or efficient to fix than doing it later when the code is just about to go in production.
And I was at a place I was working at. They were a Ruby shop, and they had Ruby gems and internal Ruby gems set up. So they would pull from the open source one after it got vetted through a certain security, right? So then security approved it for whatever, and then this was a few years ago, and then Ruby gems got hacked. But because we had this internal Ruby gems, all of our applications were protected, and a mass email went out right away not to update things, and the security team was on top of it. So there are benefits to that type of system, but it is very slow, and for startups and smaller companies, it's not an easy thing to do. And the communication, definitely, I'm very new to the security aspects of the back end, but knowing more is going to reduce the amount of defects ultimately.
Definitely, yeah.
I'm kind of wondering about new things that are opening up. The way that we approach security now is different than we have, 10 years ago, where, like you said, we relied on cookies, and now we're doing more stuff with tokens and local storage and all of this. And it seems like there's a whole new set of problems and a whole new set of attack vectors that we don't even know about yet. Do you have any ideas on how to go about mapping this stuff out and protecting ourselves from what we don't know about?
Yeah, that is tricky. So these new trends are opening up new ways of doing it, and definitely we try to close one hole and it might open another one. For me, there's no silver bullet or I can suggest one answer for that, but I think we have to just know about these basic attacks and see how it manifests in those technologies. So if you feel that there's new technology, a new way of coming, new way of developing it, I would try to map all these known existing security attacks to that technology to see if any of them still apply there or if some new one comes up. That would be the approach I would take for most of them.
Local storage in particular has had a lot of criticism as being an insecure mechanism. The mechanism itself seems to be, vulnerable. I have not personally explored this, but in some ways that you could get to it through another script or something like that. Are you familiar with the vulnerabilities of local storage in particular? Can you tell us about that?
No, actually, I didn't explore that yet. It seems interesting.
Yeah. And doing offline work, I think it'd be an interesting test for security. We had Firebase on for a little bit too, and they talked about the mechanisms that they use for storing for offline. Do you remember, Christian, was there anything specific dealing with security with that?
Well, they were doing some interesting stuff with browser crypto, actually, and they were using a combination. And I think they've since moved on, and they've abandoned their approach, but it's something that I experimented with, which is they use a combination of cookies and local storage. And if I'm not mistaken, they were using a cookie value that was generated and set locally in the browser as a secret for encrypting the payload that they got back for credentials from the server. So they would encrypt it in local storage. They could use the expiration of the cookie as a way to expire the local storage. So once the cookie expired, you couldn't actually decrypt what was in local storage. So it's a pretty interesting mechanism. I think they were using the Stanford JavaScript crypto library for that.
Also, Christian, you've had more experience than I have with this. You've been recently working with building out your Anvil.io projects with Anvil Connect. So is there new vulnerabilities with these Connect ID servers that we should be concerned about?
With OpenID Connect in general, I think that OpenID Connect addresses many of the vulnerabilities of naked OAuth 2 that certain people have brought up in a very loud way in the past. And I think that if not properly implemented, it still has potential to be vulnerable. But I have to disclose that I'm really not a security guy. So everything I say has to be taken with a grain of salt.
You're just modest.
No, really, I'm not a security guy.
So Chetan, do you have any experience with the Connect ID?
No,
Node?
no, I haven't explored that much.
Actually, I'd love to pair program with you, Chetan, and
that's
some of these that I've been working with.
definitely, yeah.
So you spoke at FluentConf about Node.js Security. I got to see the slides. It was pretty awesome going through that and seeing how Express by default wasn't so secure, and going through all the different pieces of how you can make it more secure. It's not that Express is insecure, it's just that we just don't set the defaults because there's a lot of different ways you could use Express. And I love your approach of just being totally open and honest and, hey, this is what I found in my process. So is there any overlooked security attacks from that talk that you'd like to share?
Yeah, sure. So on the same note about Express, configuring Express, the few things I shared there was just to prevent internal implementation disclosure. That is one of the things which attackers try to find. So when they find a target site, first thing they try to do is start building site's risk profile. And under that, they want to know the server or frameworks application is using. So there's one thing which Express does by default is it adds Express X powered by entry in the response header saying it is powered by Express. That is one thing we can very easily remove by removing that in app.disable entry. So that is one thing I would definitely suggest doing for Express. Another thing that I explained was changing the default session cookie name. So by default, Express uses connect.sid, and we can very easily use some generic cookie names such as session ID by setting key attribute when we create the session. So those are a few defaults that we want to change in Express. Some specific attacks, so for CSRF attack, we have CSRF middleware, but one thing that we need to be aware of there is CSRF middleware doesn't protect GET requests and head and option requests, and that is because these requests are supposed to be read-only. They shouldn't change anything on server, and that's why it makes sense not to validate that as part of CSRF attack. But when we as a developers, when we do coding, we have to make sure that our GET APIs are also not mutating. So that is one thing that we want to make sure when we're using the CSRF middleware. Another thing associated with that is there's another middleware which is called as method override middleware or module. So what this module does is it lets you use put or delete methods, HTTP methods, for the clients which don't support it. So essentially, you can still send requests with GET or POST methods, but set a header attribute to the target method, such as put or delete. And this middleware will convert those simple GET and POST requests to the desired method. So when you're using this middleware, we want to make sure that you include that or use that before including CSRF middleware. Because if you do it other way, attacker can just send GET request and that way bypass the CSRF protection, and this method override middleware will convert that to mutating methods. So that is another minor thing that we want to make sure that we take care of when we configure the CSRF protection.
Yeah, that goes back to your point of, education on these things is really key.
That's true. So a few other attacks I shared was I tried to highlight some less known attacks because otherwise OWASP top 10 is definitely a good starting place. But in that talk, that was specifically more about overlooked security attacks. I shared some denial of service attacks, such as a regular expression denial of service attack, which is caused by regular expressions. So in general, regular expressions are very fast, but there is a specific pattern which is called as evil pattern. Those regular expressions tend to take exponential execution time when certain non-matching inputs are sent for as input to those expressions. So there is pattern or there's specific requirements for evil patterns. There has to be a grouping with repetition, and inside that grouping, there has to be at least alternation or another repetition inside that. Those specific regular expressions we need to watch out for in our own code as well as in external code. So when I was working on this project, I realized there was some projects where I realized that their URL validator was insecure. So it is pretty commonly used regular expression for URL. So similarly, that is one. There are some tools to validate that as well. So probably I will share those links that you can include in this podcast that will help you in testing your regular expressions for such issues. The other thing which was about HTTP parameter pollution attack, where attacker can very easily add multiple query parameters with same name and array in Express that those values are populated inside an array. So because of that, it might happen that if you are applying some string-specific methods on those inputs, assuming that those are always strings, that could cause some type errors in your code. So that's why it is very important to do type validations when we type checking when we validate inputs. Also, doing type checking also prevents some type of NoSQL injections, because in NoSQL injection, attacker sends an object instead of a string. So type checking definitely helps there. Pretty much that was the gist of that talk.
And you're talking at JS Summit as well, which is an online one. Probably by the time this is released, it will be over. But this is you're speaking this Friday, which would be the 21st.
20th. I'm speaking on Thursday, 20th.
I'm sorry, Thursday the 20th. Yes, this will definitely not be out by then. But will this be available? Can people view the videos?
Yeah, so videos probably I'll have to check, but I can definitely share the slides on the speaker deck site.
Nice. Yeah, that'd be awesome. And what makes this talk different than the one from FluentConf?
Yeah, so it is just a little expanded talk. So I added a few more things in this talk because this was for longer duration. I was having a little more time this time. So Fluent talk was for half an hour. This is like 1 hour talk. So I expanded some of the contents, giving some more examples, adding some more topics within that.
That's great. So is there anything else as far as, Node.js security or JavaScript security that we should be aware of for applications?
Yeah, I think pretty much that's all. But if I have to summarize the security for Node.js security issues, I would just say it's more of a battle of awareness than complexity. Just stay informed about basic OWASP top 10 risk at least. And when we do technical decisions, consider those, as well as stay aware of the vulnerabilities coming in the Node modules, Node.js, any frameworks we use, and keep them up to date. I think if we just do that at developer level, I think we are in pretty good shape.
Nice. As you know, most of the stuff I do is a lot of front end. So a lot of the security stuff that I'm familiar with is on the front end, but I do some Node applications. Your talk was really enlightening. I cringe, like in Angular, there's some, safe HTML functions that you can use to get HTML, and then that sort of opens you up for a lot of targets with these things. But it's, an opt-in, which is, you have to, it's not by default, right? So I'm shocked at when I talk with clients, and they're like, oh, we don't care. We want a rich text editor. And they're like, yeah, just throw the HTML in there. And I explain to them the risks of a lot of this, and they just don't care in some cases. And that's kind of scary to me. And then you say yes, as you like. But as long as you've told them about it, and and you've made them aware. And that's what you need to do is to stand up and say, hey, this is not the right way to do it, right?
Yeah.
So thank you so much for coming on, Chetan. It's always great to talk with you, and it was nice excuse to catch up for sure.
Definitely, same here. It's my pleasure.
Do you have anything you want to plug as far as things that are coming up? You got the JS Summit, and what else? I know you're still at Omgeo, so we'll put a link to Omgeo's site. Is there anything you want to plug while you're here?
Well, for now, I would just let everybody to stay tuned with the NodeGoat project itself. We have some new versions coming there. I will probably add some more tutorials in there, some videos, some screencasts. That is something definitely we should keep watch on.
If people want to find you or chat with you or pair program with you, how can they get in touch with you?
Yeah, I would love to. So feel free to reach me for any kind of feedback on this talk or in general, any pair programming opportunities. I would love to do that. So my Twitter handle is at the down. You will put that in the resources, right?
Yeah.
That is the best way to reach me.
Yeah, it's at KARANDE, right, _C.
Yep.
Thank you so much. I think that's a wrap.
Great. Thank you, Eric. Thank you, Christian.
This episode comes to you, at least in part, through the support and sound equipment generously supplied by 3 Pillar Global. 3 Pillar is a software product development company in Fairfax, Virginia, and 3 Pillar is a leader in creating purposeful and innovative product experiences. 3 Pillar was recently named to the Washington Post Top Workplaces list for 2014. So if you want to follow 3 Pillar on the Twitters, it's at 3 Pillar Global. And to find out more and see current job openings, please visit 3pillarglobal.com. That's 3, the number, pillarglobal.com. Thank you.